Hello everyone, welcome to my channel. Now in this video we are going to learn about basic concepts of algebra, and this is first lecture. So here we'll discuss about the basic definitions which we are going to use in algebra. Let's get started. One should learn algebra to develop critical thinking, including problem solving, logic, patterns and reasoning. And sometimes we are using this algebra in our daily life without knowing it. In algebra, we use letters to represent unknown quantities like A, B, C and so on till Z. And this letter talk about any number, not a particular number. Like A can be 2, 3, 4 until infinity, any number it can be. In algebra, we use these letters to write rules and formulas in general way. And we use these rules and formulas for solving our problems. As these letters represent numbers, so we can perform all the operations on them like addition, subtraction, multiplication and division. So now first we will discuss about few definitions which we are going to use in algebra. Let's get started. Here first we have constant. A constant has a fixed value. Its value doesn't change. For example, in arithmetic we have used digits 0 to 9. All these have fixed value and all these are constants. Next is variable. A variable does not have any fixed value, and variable also known as literal. And in algebra we represent our variables with English alphabets like A, B, C, D, X, Y, Z. All these are variables. Always remember few points over here. First is a combination of two or more than two constants is always a constant. For example, if I divide 5 and 3, I will get a constant value. Similarly, if I add these two, I will get a constant value. If I subtract these two, I will get a constant, because all these digits are constant. And second point is a combination of two or more variable is always a variable. For example, if I have two variables A and B, if I add them, I will get A plus B. This is also a variable. If I multiply these two, I will get a variable. Similarly, A divided by B is a variable. All these things. A minus B is also a variable. And third point over here is a combination of a variable and a constant or more than constant is always a variable. For example, I have this is a constant and A is a variable. And if I add 3 and A, what will I get? I will get a variable. Correct? So next definition is term. What is a term? Term is a number which we are calling here constant, a variable or combination of constants and variables. For example, 3 is a constant and this is a term. 3a, which is also a term, the combination of constant and variable. This is a term. And the combination of two variables also a, b or x, y, all these are terms. And always remember this a, b is equal to a multiplied by b. In algebra, we skip this multiplication and we simply write this a multiplied by b with like a, b. Next, we have algebraic expression. An algebraic expression is a collection of one or more terms which are separated by plus or negative signs. For example, 3x, this is an algebraic expression. 3x minus y, this is also an algebraic expression. 3xy plus yz minus 2, all this is also an algebraic expression. And always remember that plus sign and negative sign are used to separate terms. For example, in this 3x, we have 3x is an algebraic expression and here we have only one term. Similarly, 3x plus y, we have two terms. First 3x and y. And 3x minus yx, we have two terms which are 3x and minus yx. One more thing which we have to note here is that the signs of multiplication and division do not separate the terms. For example, if I have 3x square multiplied by 4y, here 3x square and 4y are not different terms. This forms a single term. Similarly, x upon y, this is also a single term. They are not different terms, means x is different and y. It is not like that. This forms a single term. Now let's discuss about different type of algebraic expressions. First we have monomials. Monomial is an algebraic expression which contains only one term. They have only one term. For example, 3x, 3xy, 9x divided by y, all these are monomials because they contain only one term. Next we have binomials. Binomial is an algebraic expression which has only two terms. They have two terms. For example, 3x plus xy, because there are only two terms, 3x and xy. Xy minus z, this also have two terms, xy and negative z. Next we have trinomials. Trinomials, these are those algebraic expression having three terms. For example, 3x plus z plus y, 4x plus x upon z negative y upon z, all these are trinomials. They have three terms. Next we have polynomials. The polynomial is an algebraic expression which contain more than one term. So we can say all the binomials, trinomials are polynomials. Next definition, here we have product. When two or more quantities, these quantities can be constant, variable, or both are multiplied together, the result is called their product. For example, if I multiply this here 4xy, this 4xy is a product of 4x and y. Similarly, 9a, this is the product of 9 and a. Next definition, we have factor. All the quantities, it can be constant or variable, multiplied together to form a term is called a factor of the term. For example, if I take 3xy, so here 3x and y are the factors of term 3xy. So in other way, we can say that we can divide this 3xy with 3x and y. That's why 3x and y are the factors of this 3xy. And so on. Similarly, here I'll take 9a. So the factors of 9a are 9 and a, because I can divide this 9a with 9 as well as a. And next we have coefficient, and this we use only for a monomial algebraic expressions. So in a monomial, any factor of a term is called the coefficient of the remaining part of the monomial. For example, in this 6xy, we know 6x and y are the factors of term 6xy. So here any factor we can take 6. So we can say 6 is the coefficient of remaining part of the monomial, means remaining part is xy. Similarly, x is the coefficient of, what is the remaining part? 6 and y. And y is the coefficient of 6x. Suppose if a factor is a numerical quantity that is constant, it is called numerical coefficient. For example, here 6 is the numerical coefficient of xy. This is numerical coefficient. This xy is also a coefficient of 6 and it contains only variables x and y. So we can say this xy is a literal coefficient of 6. Next definition, here we have degree of monomial. The degree of monomial is the power of its variable or the sum of the powers of its variables. For example, in this, if I take 4y square, here the variable component is y and this is constant that we know. So here the power of the variable is 2. So this 2 is the degree of the monomial 4y square. Second, I'll take one more example, 7y. So here see the variable component is y. So what degree it has or what power it has? It has 1 power. So we can say the degree of this monomial for 7x is 1. If I take one more example, 3x square plus y square. So here how many variables we have? We have 2 variables, x and y. So what are the powers of these 2 variables? The x has 2 power and y also has 2 power. So we have to add these 2 power. So we can say the degree of this monomial 3x square and y square is equal to 2 plus 2, which is equal to 4. Next we have the degree of a polynomial. The degree of a polynomial is the degree of its highest degree term. So here first we have to search out for the highest degree term. Let me take one example. For example, I'll take 6x raised to power 4 plus 9x raised to power 4 and y raised to power 3 plus 2xy. So here in this polynomial we have 3 terms. First is this, second term is this and third term is this. So the degree for first term is, here the variable is x raised to power 4. So it means the degree of 6x raised to power 4 is 4. So here what we have to do? We have to add these degrees of 2 variables. So here the variables are x and y and we have to add their degrees. We'll get 7. Similarly here the degree of this term 2xy will be this 1 plus 1, which is equal to 2. The higher degree term is this. So we can say the degree of this polynomial is equal to 7. And next we have like and unlike terms. Like terms are the terms have same literal coefficients. And what are the unlike terms? And unlike terms, they do not have same literal coefficient. For example, five x and 3x are like terms because they have same literal coefficient x and x. Similarly, 7x square and 3x square are like terms. They have same literal coefficient x square and x square. And for unlike terms, we can say 5x and 3y. All they do not have same literal coefficient. It has x and it has y. So they are not like, we can say they are unlike terms. Similarly, 3x square y and 4xy square are also unlike terms because they do not have same literal coefficient. So we have learned here all the basic definitions which we are going to use in algebra. Thank you everyone for watching my video.